Hey friends, price elasticity of demand, PED, measures the responsiveness of quantity demanded of a good to changes in its price. So for example, imagine this. You sell sea salt and you want to increase the prices of your salt by $10 per kilogram. Should you do it? Now, imagine you sell shoes in an online shop and you want to increase the prices of your shoes by $10 a pair. Should you do it? You may have a gut instinct to raise prices for salt, but not raise prices for shoes. Why? Well, you may think that everybody needs salt regardless of price, but people can buy shoes from another online shop. So changing prices could affect the total quantity demanded, which then could affect your revenue positively or negatively. And this simple example shows us why it's so important to understand elasticity. Price elasticity of demand measures the responsiveness of quantity demanded of a good to changes in its price. And as we see in this formula on this particular screen, the price elasticity of demand has two components, the quantity demanded on the numerator and the price in the denominator. Well, quantity demanded is influenced by price. So QD in this formula over here is the dependent variable here, which is the Y value, and price is the independent variable, the X value. The term responsiveness in the definition of PED signals that these price and quantity demanded are responding or changing, and therefore there is this triangle over here. And the changes are measured in terms of percentages instead of absolute values, which is why we use a percentage over here in this formula. Now, when you apply this formula in your calculations, especially in paper 3, you'll notice that the PED values usually end up with a negative sign. And this is perfectly normal because the negative sign signals a negative causal relationship between price and quantity demanded, which is what you've learned in the previous chapter on demand and supply. But usually in exams, especially in paper 3, we drop the minus sign from our responses. So as we see in this particular diagram, PEDs exist on a spectrum from perfectly inelastic demand, whereby your PED equals to 0, and this is reflected in this diagram over here, to a perfectly elastic demand, whereby your PED value is infinite, as we see over here. But the truth is that most goods usually have demand that is either elastic or inelastic, and they are reflected in these two diagrams over here and over here. So I'll dive into these two diagrams specifically and outline what they mean. So in the first diagram on the left, on diagram A, we see that a 10% increase in price from P1 to P2 only leads to a 5% decrease in the quantity demanded from Q1 to Q2. So what does this mean? Well, this means that the proportion of price increase is higher than the proportion of decrease in quantity demanded, which means that the overall demand for this particular good is inelastic. And using the formula above, the PED value is 0.5 because we took 5% divided by 10%. And this is why goods with inelastic demand have a PED that is below 1. In the second diagram, a 5% increase in the price, as you see over here from P1 to P2, leads to a 10% decrease in the quantity demanded from Q1 to Q2. So this means that the proportion of price increase is lower than the proportion of decrease in quantity demanded. And this means that the demand for this particular good in diagram B is inelastic. And using the formula, the PED value is 2 because we take 10 divided by 5. And this explains why goods with elastic demand usually have a PED value that is more than 1. And if we see if that the PED value is exactly 1, this means that the proportion of change in price is identical or equal to the proportion of change in quantity demanded, as we see in diagram C. So one point to note that I've mentioned earlier is that the slope of a demand curve is not the same as the PED value. As we see in this particular diagram, there can be multiple PED values along the same slope. But as we've learned from our math classes, one curve should only have one gradient, especially since this is a linear straight line. So by extension, the gradient of the demand curve is not the same as the PED. And this is a point I really want to hammer home because it is a very common mistake made by many students. So don't fall for this trap. Now moving on to determinants of PED, there are 4 primary determinants of PED. Just like how demand in the previous chapter has non-price determinants, there are 4 key determinants that influence our understanding of PED. The first one would be number and closeness of substitutes, as we see over here. So, a good with more substitutes usually has more elastic demand. So, for example, a phone as a category has no substitutes. So, demand for phones is quite inelastic because consumers can't switch products from phones to something else. But in contrast, an iPhone has many substitutes. So, the demand for iPhones is usually more elastic. And if iPhones become more expensive, some consumers can switch to other phone brands. And this also explains why, in terms of product types, primary commodities such as things like cotton, grain, wheat, they usually have a low PED, while manufactured commodities such as things like cake, phones, etc., have a higher PED because primary commodities are necessities with very little to no substitutes, while manufactured products usually have more substitutes. The second determinant of PED is a necessity versus a luxury. So, for example, rice versus caviar. Necessities usually have inelastic demand, and luxuries have elastic demand. For example, necessities such as electricity is usually price inelastic. You still need electricity, even if your price increase. But luxuries like a car, I would say, have a more price elastic demand. You can choose not to buy a car if the prices are too high. The third determinant of PEDs would be the length of time to purchase something. So you are considering between a longer time frame before you make a purchase versus a shorter time frame before you make a purchase. Usually, naturally, if you wait longer to buy something, demand is more elastic. Think about it. Imagine if you purchase something on Amazon and you leave it in your cart while you think about it, you'll find that the longer you wait, you'll be a bit more responsive to changes in its price because now you can compare its price with other websites or wait for discounts before you make the purchase. And the last determinant of PED will be the proportion of your income spent on a good. Do you spend a large proportion of your income to purchase something, or do you spend a small proportion of your income to purchase something? Usually, the higher proportion of an income you spend on a good, the more elastic demand becomes. Imagine buying a book versus a car. The same percentage change of price in both could lead to a massively different quantity demanded for both. So why do we even need to know about PEDs? Well, there are 3 real-world applications. Firstly, to project revenues. Secondly, to set prices. And thirdly, to even set taxes, especially for the government. These diagrams below show what I mean. So as you see in the first diagram, if a good has a more elastic demand, as we see in diagram A over here, increasing the price by $1, right, from 4 to 5, will lead to a decrease in quantity demanded of 3 units. So the potential revenue gain, which is area C in this diagram, is actually smaller than the potential revenue lost, which is area B over here. If you look at the area of that rectangle, area C is smaller than area B. So as a result, if the firms don't want to lose revenue, they should not increase their prices. But now let's look at diagram B, where demand for the good is inelastic. Increasing prices by $2, as we see over here, leads to a decrease in only 2 units of output sold, as we see over here. But now let's look at the impact on revenues. Potential revenue gain, which is area C in this diagram, has a larger area than area B, which is the potential revenue lost. If I'm the firm, I would definitely increase prices because I have the potential to earn more revenue if I increase my prices. So these 2 diagrams show how knowing the elasticity of demand helps firms to set prices to project revenues, or maybe even taxes, because taxes are a form of government revenue. So these diagrams hopefully are helpful in your understanding of how PED applies to our real-world examples, especially if we own a business.